All right, so we're going to start with using equations or solving equations with only integers. So there are no parentheses, so we don't need to use the distributive property. And the left side doesn't have any like terms. 9x and negative 10 are not like terms, and the right side does not have any like terms. 2x and 11 are not like terms. So we'll move on to the next step, where we need to separate our variable and constants by using addition and subtraction properties of equality. So I'm going to make the left side my variable side, and I'm going to make the right side my constant side, or my numerical side, with just numbers. The reason I chose that is because if I were to subtract 2x from the 9x, I would still have a positive coefficient. If you want to do it the other way, that is fine. It's just you have more room for error when multiplying or dividing by negatives. So I'm going to get rid of this plus 2x by subtracting 2x from both sides. So I now only have a variable term on the left side. Hopefully this looks familiar, and it just looks like a two-step equation, which we have spent a lot of time on preparing for this new type of equation. So now we're going to just isolate the variable term over there. So we're going to now move the constants to the same side. So we just moved the like terms to each other. Now we need to do it with the constant. So let's add 10 to both sides. It's going to cancel it out on the variable side, leaving us with 7x equals 21. Now we have a one-step equation. They're touching. That's multiplication. So we are going to divide to isolate that variable, and that gives us x equals 3. Please pause the video to write this down, because I'm about to erase and show us how to check our answer, our solution in our equation. All right, so we said that our answer was 3. So we had x equals 3. What we're going to do is we're going to go where everywhere there is an x, and we're going to replace it with 3. We're using parentheses to show that that's not 93, that it's 9 times 3. And then we're just going to evaluate each side independently. So the left side, we have 9 times 3, which is 27. 27 minus 10, which is 17. So if we are correct, then the right side will also simplify to 17. So 2 times 3 is 6, and 6 plus 11 is in fact 17. So because once we plugged our values in, it balanced the equation, that means that that was the one solution that made this true. Now on the last equation, we had a choice. We could move the variable to either side. But here, we already have just one variable isolated on the right side. So it's like it already chose that to be the variable side. So you have to move the other variable to its like term. So I'm going to add 4x to both sides. So we're bringing down our 12 and our 6x. It's just a one-step equation again. Get rid of the multiplication by dividing. And we end up with x equals 2. So then we can plug that in using substitution. So we're going to substitute it in for x's to check our answer. I'm just going to show it over here. We have 12 minus 4 times 2 should be equivalent to 2 times 2. So on the left side, that gives us 12 minus 8. 12 minus 8 is 4. And 2 times 2 is also 4. So because it's satisfied and made this equation true, that means our solution is correct. So now I want you to try number 1 on your own. And then the question off to the side will ask you to input your answer. Once you put your answer in and you submit it, I will show the work for the problem. All right, so for your first example on your own, you should have gotten x equals negative 3. So one thing that I think you should keep in mind is that these are 1x's. So if that helps you with subtracting, and also make sure you bring down the negative side with that 5. One way to help with that is if you wanted to rewrite that as x plus negative 5, just using your integer rules, just doing keep, change, opposite. That's one thing that you might have made an error on, but check your work and see if that was it. All right, so now you're going to try number 2. So same thing, once you input your answer off to the right and resume the video, the answer will appear. All right, so for that one, you should have gotten y equals 2. So same thing as the second example that we had done together. There was already a variable term isolated, so that automatically became our variable side, and we moved the like term, the other variable term, to it, and then just solved a one-step equation. All right, now we're going to kick it up a notch and add some rational numbers in there. The process remains the same. The only difference is we might be operating on fractions. So I'm going to go ahead and pick my variable side and my number side. So I just chose the variable side on the left because when I subtract that x, I'll have a positive coefficient. There's no parentheses or anything here, so we're going straight to separating those constants and variables. So I'm going to subtract x from both sides. Remember, you can think of that as a 1x. And I end up with 4x minus 2/3 equals 5/6. All right, so now we need to move on to getting our constants on the same side. So I'm going to isolate this variable term by adding 2/3 to the other side. Now, when we're operating with fractions, remember that when you're adding them, you have to have a common denominator. So for 3 and 6, the LCD, the least common denominator, is going to be 6. So the first equation is, or excuse me, the first fraction is not going to change. It's going to remain 5/6. Plus, now we need to figure out how to rewrite our second fraction to have the same denominator. So to do that, you would have to multiply the denominator by 2. So to keep it as an equivalent fraction, do the same thing to the top. So that gives us 9/6, which can be reduced. They are both divisible by 3. Let me write this up here. So what I got was 9/6, and I am simplifying by 3, and that will give me 3/2. Or you can write it as 1.5. If it's ever repeating decimal, when you divide it, you have to keep it as a fraction though. All right, so last step, we are going to divide both sides by 4. Remember, dividing by 4, you can write that and then do your keep, change, flip. Or, since we know we're going to be dividing fractions, you can go ahead and jump straight to multiplying by the reciprocal. So if we multiply straight across, we end up with 3/8. So x equals 3/8. So yes, it looks a lot more complicated, but the only thing that was different was having to operate on those fractions. All right, the next one is the first place that we are seeing those parentheses, so we will have to distribute. And we're going to have to distribute on both sides for this one. So I'm going to start with the right side. It's a little bit easier. We've got 5 times x, which is 5x, plus 5 times 8, which is 40. Now, to multiply 2/3 by these terms, we need to turn them into fractions so that way we can multiply straight across. So 2/3 times 2/1 is going to give us 4/3 x, minus 2/3 times 6/1 is going to give us 12/3, which we will simplify. 12/3 will simplify, and I'm just writing it so we can see where it's going and where it's coming from, to 4. So now you see that once we've done that distributive property, it is the same as the other examples that we had done, except for this fraction coefficient, but we know how to handle that. All right, just clean it up a little bit there, make it easier to follow me. So same thing, we need to get our variable terms on the same side. So this time, 5x is bigger than 4/3 x, so I'm going to subtract 4/3 x from both sides. So I'm making this my variable side. If you do it the other way, you'll still get the same answer. I'm just going with the easier one for me. So make sure you bring down that negative sign with the 4, and we will operate on that in a second, and whatever it is going to be plus 40. So I'm going to come off to the side. We have 5x minus 4/3 x. So we're just subtracting the coefficients. So I'm even going to erase these x's here because they are like terms, which allows us to subtract them. So right now, this is currently a 1 as the denominator. So the first multiple that they have in common is 3. So the second one, we're not going to have to rewrite. To get 3 on the denominator there, we'd multiply by 3. So we have to do the same thing to the numerator. We end up with 11/3. Oops, wrong place. 11/3 x. All right, I moved it over so we have more room. So now it's just a two-step equation. We have our variable on the right side. Now we need to get both of our constants on the other side. So we're going to subtract 40. Be careful with your integer rules. Negative 4 minus 40 is the same thing as negative 4 plus a negative 4. So we have negative 44 equals 11/3 x. So we have a one-step equation left with a coefficient that is a fraction. So since they're touching this multiplication, the inverse would be to divide, but we know dividing by fractions, you actually multiply by the reciprocal. So any fraction times its reciprocal is going to give us 1. And then we have 3 over 11 times negative 44 over 1. We're multiplying, so we do not need a common denominator. But I'm going to cross simplify here. 11 and 44 are both divisible by 11. If you don't want to do that, you can do it the long way. Go straight across and then reduce. And we get 3 times 4, 3 times a negative 4, which is negative 12 over 1, which we don't need to write. So our answer over here is going to be x equals negative 12. These are probably the ones you want to be checking your answer with. So let's go through and check our answer on this one. We have 2/3 times 2 times negative 12 minus 6 equals 5 times negative 12 plus 8. All right, so the right side looks easier to do. We'll tackle that one first. Negative 12 plus 8, that gives us 5 times negative 4. 5 times negative 4 is negative 20. All right, so over here we need to simplify the inside first. We have 2 times negative 12, which is negative 24, and then negative 24 minus 6 is going to give us negative 30. So we end up with 2/3 times negative 30. And all I did was follow the order of operations there. You could even use your graphing calculator if you use all the right grouping symbols. All right, so 2/3 times negative 30 gives me negative 60 over 3, which reduces to negative 20. So since our solution, x equals negative 12, made the statement true when we substituted it in, we know we're correct. All right, now it's your turn to try. When you are done, submit your answer, and then the work in the answer will be shown. All right, so you should have gotten x equals negative 50. As you can see, I brought off the work for the fraction operation off to the side. I did not show the last step, but I will talk you through it. 1/5 times x, I got rid of it by dividing by 1/5, which is multiplying both sides by 5 over 1. So that's how I got negative 50. All right, so all the problems we've done so far have been one solutions. That means that one answer has made our equation a true statement. So the solution of an equation is the value or values of the variable that makes the equation a true statement. So like I said, we have done one solution so far. There are also infinite solutions, which we will look at. And there is possibly no solution to certain equations. So these are the 3 different types of solutions whenever we have an equation in one variable. So that means that there's just one variable term. So you can't have like an x and a y in the same equation, or 2z or a z and an x and a y in an equation. So it has to be just in one variable. So that way we can separate one type of variable term from the constants. So to talk a little bit about those types of solutions, a one solution means that only one value makes the equation true. Like I said, that's what we have been doing up until this point. It is a conditional equation, which is true for some values of x. So dependent, like there's a condition that makes it true. Infinite solutions, any value will make that equation true. That's called an identity. That means that it's always true for any value of x. So basically, once simplified, the left and right side of the equation would have the same identity, meaning that whatever number got plugged in would be treated the same and it would have the same outcome. And then you have a no solution, which means that no values will make the equation true. It's called a contradiction. So it contradicts itself. It's asking you to solve it, but there's nothing that will actually work in terms of solving it. So nothing is ever true for any value of x. So let's look at our first example. I'm going to do one of each with you. So we're going to go ahead and get rid of those parentheses. We're still working off those steps from the very first slide. It's just our outcomes and the number of steps and change as we go through. So we have 8x plus 10 equals 10x plus 20. Let me change that color. That one's not very easy to see. All right, so let's pick a variable side. I'm going to make this my variable side because if I subtract 8x from it, it's still positive. So minus 8x from both sides, leaving me with 10 equals 2x plus 20. And then I'm going to get my numbers, my constants on the same side. So I need to get the 20 away from the variable term and to its like term on the other side. 10 minus 20 is the same thing as 10 plus a negative 20. So that's negative 10 equals 2x. So now that we have a one-step equation, I'm just rewriting it because we ran out of room. It's multiplication, undo it with division. So we have negative 5 equals x. So there is a solution to this one. There's one number that we got at the end. So this equation has one solution. And that means that one value of x will satisfy, that means make it true, the equation. So nothing else plugged in would make a true statement except for negative 5. All right, so this example allows us to practice some other things that were in our steps for multi-step equations that we haven't covered yet in this video. So we have to start by using the distributive property always. So this is going to give us 10x plus 8 minus 11 equals 4x, because that's not in the parentheses or touching it, it's separate, so it just comes down, plus 6x minus 3. So what we haven't come across yet is when you have like terms on the same side. So I'm just going to clean this up. I've got the positive 8 and negative 11 that are like terms. I'm not doing anything inverse. They're on the same side. So this is simply 8 minus 11, or 8 plus negative 11. So this would become 10x minus 3. Now we need to clean up this side. We have like terms, 4x and 6x. So we're going to add those, and that will give us 10x minus 3. So hopefully you already noticed something, that the left side and the right side are identical. So before we even keep going, I know that this has infinitely many solutions. And what that means is that this means any value of x will make this equation true. So the best way I like to explain this as, think of you're ordering something online. So company A charges $10 per cup. I'm looking around my room, sorry. So like a Tervis tumbler. And then you have a $3 coupon. So it's $10 per cup minus 3 because of the coupon. Well, this other website has the same exact deal. Will it ever matter if you go to one or the other? Will one ever be more expensive than the other? They're always going to cost the same. So at any point in time, no matter how many cups you buy, if it's the same cost, you got the same coupon, it's always going to cost the same at the end. So when you're checking these ones, well, first off, we can go ahead and finish it. So let's work it all the way out to see what happens. So I'm going to get my variable on the same side, but watch what happens. It doesn't matter which one you move because either way, it's going to cancel out. And you're left with negative 3 equals negative 3. So one way to also work this out is before, if you haven't recognized that it's an identity earlier on in the steps, and once you get to that final statement, negative 3 equals negative 3, if it's a true statement, that means that anything will make it true, making it an infinitely many solution. But back to what I was saying before. So say I bought 2 cups. So it does not matter where I bought them. Both sides are the same, but I'm going to go ahead and humor ourselves to prove it. So we have 10 times 2, which is 20 minus 3 is $17. And over here, 20 minus 3 is 17. So when you check it, you can plug in anything. You can plug in 1,000,000 and it's still going to be balanced because it's an identity. Both sides are going to operate on the numbers the same way. Any value of x will make this equation true. All right, we have another kind of long-winded one. So once again, look for parentheses. Remove the parentheses by applying the distributive property. So we have negative 4x plus 15x plus 18 equals 14x plus 7 minus 3x. We want to clean up the sides if there's anything to be cleaned up. So we're just looking here. We do have like terms. So that's going to give us 11x plus 18. Then we're looking at the other sides. We do have like terms. That gives us 11x plus 7. So here we can see that the variable terms are the same. They're identical, but the constants are not. So I would like to work this one out completely so we see what happens. We subtract 11x from both sides. They cancel out, and you're left with 18 equals 7, which is a false statement, making this a no solution. So this means no value will make this equation true. All right, so let's think about that same scenario. So say it is $11 for a blanket, and then this company charges $18 for shipping. This one charges $11 a blanket, but $7 for shipping. So if you were trying to decide between these two, obviously if they're cost the same amount each product, and then one's giving a better deal on shipping, you're always going to go with that one. There's never going to be a time where both companies cost the same. So, for example, say I bought 2 blankets. So that'd be 11 times 2 plus 18 for the left side company. And then the other one would be 11 times 2 plus 7. So that'd be 22 plus 18, which would be, I think, 40. 22 plus 18, 40. And then the other side will be 22 plus 7, which is 29. So you can see that they're not going to cost the same. And there's no way to even check these because you could plug in, numbers to anything, for a one solution and only one of them is going to work. I mean, here, nothing you plug in is going to work. And then with the infinite solutions, anything you plugged in works. So here, if you get that false statement at the end, like where we had 18 was not equal to 7, it's a no solution. All right, so you have 3 problems to try here. So first, we're going to do one at a time. So number 4, then you're going to put your answer in. I'll have the answer up, but I'm not going to show the work this time. Number 5, put your answer in, so on and so forth. So go ahead and try number 4. And when you submit your answer, the correct answer will be on the video. All right, so for the first one, you should have gotten a no solution. And a shortcut to drawing that, or instead of writing it, unless specifically asked, is this circle with a cross through it. That also means no solution. All right, so try number 5, enter your answer, and then when you submit it, the answer will come up. All right, that was a 1 solution. Now, when you have a 1 solution, you might have written 1 solution down, but not necessarily is that needed. Instead, you would actually give the solution since there is a specific solution. All right, so try number 6, and then when you submit your answer, the video will resume and the answer will be there for you to check. All right, so that one had infinitely many solutions, and there is also a shortcut to writing that one, and it is just the infinity symbol. Make sure that you're not just using the symbols, that if someone said, hey, what's that symbol? You can say, oh, it's a no solution. Or, hey, what is that symbol? It means infinitely many solutions. So don't replace it, but you have a backup for, writing on your answers on your paper. Okay, so there's one more thing that we need to discuss. And that is our watch out problem, meaning that this is the biggest mistake I always see, and I want to make sure to help you not make that same mistake. So we're just going to start solving it like normal, and it's not until the very end that you might be confused. All right, so we're going to distribute. To get rid of those parentheses, we have 14 plus 35 V. All right, and bring down the other side because there's nothing to simplify over there. All right, let's choose a variable side. I'm going to choose this to be my variable side and this to be my number side. Nope, other way around. This to be my variable side and that to be my number side because I would rather subtract 3V than subtract 35V. So getting the variable on the same side, that leaves us with 14 plus 32V equals 14. And now I'm going to subtract 14 from both sides to get the constants on the same side. And we end up with 32V equals 0. Now we're going to divide both sides by 32. Because even though we have a 0 over there, a lot of people say, oh, 0, there's 0 answers to this. No, 0 is still a value. 0 can still be a solution. So when we divide both sides by 32, we see that the answer is V equals, well, simplify that, it's 0. Do not be mistaken and think that a 0 as the solution is a no solution. It is still a value that can be plugged in to satisfy an equation.